Good morning, students. Today we are going to discuss about the KNN algorithm. So the topic which we are going to cover in this discussion is we'll discuss why we need a KNN, what is KNN exactly, how to find the factor of K, when do we use KNN, and how does KNN algorithm work. So all these things we are going to discuss in today's lecture. So first of all, what exactly the KNN is? KNN algorithm assume that similar things exist in a close proximity, or we can say that the similar things which are near to each other, they belongs to same category. Suppose we'll take a simple example, and with that we will understand that how KNN works and how we are saying that similar things which are in a close proximity can be of a same class. So first of all, before discussing deep into KNN, we'll discuss why we are using KNN actually. So when we are talking about any machine learning algorithm, most of the machine learning algorithm works on the past availability of the data. We are giving the data to the model and we are asking model to learn, and we are finally predicting the outcome from the learning. So this is generally a machine learning model works. So we take a simple example and we'll understand that how KNN works in the same scenario. See, a mother and a daughter is walking in a park, and a daughter saw cat first time, and daughter saw something first time, and she asked, "Is this a dog?" She asked her mother. Then she said, mother said, no, this is not a dog, this is a cat, because there is a difference between cat and dog. So mother first time she is telling the difference between the cat and dog. So we know there is a difference between cat and dog. Cat will have a sharp claws used to climb. Dogs will have a dull claws. Cat will have a smaller length of ears, but comparatively dog will have a bigger length of ears. Cat will say meows or purr, dog will bark, and cat will doesn't love to play around, but dog loves to play around with human being. So this is the basic difference between cat and dog, which we know. But a small child, when first time he or she will see cat or dog, he cannot differentiate what is the difference between cat and dog. Now, with the help of all these differentiation, I want to know that image what a kid has seen first time, she want to differentiate that this is a cat or dog. So we are taking two features into consideration, like length of the ears and sharpness of claws. We are taking these two features, and using these two features I want to identify that given image is a cat or dog. So you can see here, this in this image, this particular cat is having a sharp claws. Okay, so we can say it belongs to a category of cat. So I can differentiate that this is a cat because the most of the features of this belongs to cat. So this must be a cat. So finally mother told this is a cat. So we have identified. Suppose now the question is how KNN comes into the picture in this case. So suppose I'm saying that it's similar to something, then we'll say it is a cat. If it's more similar to dog, we'll say it is a dog. So I'm considering this image, I'm comparing with this five images, the four cat images and one dog images. So when I'll compare with this, most of the features of this cat belongs to these features. So that's why we are saying this is a cat. So I consider total five data set points, and from these data set points, I'm comparing the value of this features with the other features, and finally I'm taking a decision that it is a cat or dog. Okay, so in that way KNN works. So KNN works in the feature similarity, and according to the feature similarity, we are going to do the classification. So I hope you understood. Basically, KNN is used for classification purpose, and here we are doing the feature similarity matching. So most of the features will match with one type of image. So we'll say that this is a cat. If doesn't match, we'll say it is a dog image. Okay. So we can say what exactly the KNN algorithm is. KNN is nothing but a K nearest neighbor, and it is a supervised machine learning algorithm. And in most of the cases, KNN is used for classification purpose, where we will check the data points based on how its neighbor are classified. So the classification of new data points will depend on the classification of the nearest neighbors data points. Accordingly, the classification will be done. So we'll take another example and we'll understand again in a better way that how KNN works. Suppose we have a red wine and white wine with us. So the red wine or white wine depends on the level of chloride and level of sulfur dioxide level. So if level of sulfur dioxide is high, then we'll say it is a white wine. If it is a level of chloride level is high, we'll say it is a red wine. So now we got a new sample and I want to know that this new sample belongs to red wine or it belongs to white wine. I want to differentiate this. So I said that in the case of Canaan, we are considering the nearest neighbor. So what is my k value in this case? I'm considering 5 nearest neighbor. And using this 5 nearest neighbor, I want to classify that this new data point belongs to red wine or a white wine. So what are the nearest 5 nearest neighbor data points to this? We consider these are the nearest neighbor. These 4 are nearest to this and this plus 1. So total 5 nearest neighbors are there. And as you can see that most of the neighbors belongs to which class? Red wine class. So we will say this the new data point belongs to red wine, not to white wine. So accordingly, we have taken the decision. So we consider the neighbors and most of the neighbors belongs to which class? The new data points will also belongs to the same class. In that way, K-NN algorithm works. Okay, so understood how it is working. We have to decide the K value. So in this scenario, we have taken K value as 5 and we have taken the decision that this particular sample data belongs to red wine because most of the data points which we have taken into consideration belongs to red wine class. So this new data point also belongs to red wine. So I hope it is clear. Now the question is how do we choose the value of k? That is the biggest question in the case of KNN. How we identify the what should be the value of k? Finding the right value of k is a biggest task in KNN algorithm, and this is also called the parameter tuning. If we have a better value of k, there is a high chances that we'll get a better accuracy of the model. We'll take a simple example, and with that you can understand that how k matters in KNN algorithm. See here, we have 2 squares and 1 triangle and we got a new data point and I want to know that this data point belongs to square class or belongs to triangle class. So I want to know this. So you see here we have taken k value 3. When I'm taking k value 3, so most of the neighbors belongs to what? Belongs to square class. So I'll say the new data point also belongs to square class when I'm taking k value 3 because 2 data points belongs to square and 1 data point belongs to triangle. So I can say it belongs to square class. Fine. Now take another example. Here I'm taking k value 7. If I'm taking k value 7 and I want to find the label of new data points, you can see here if I'm taking this into consideration, so what should be my k value? Now my k value I have taken 7. Now I have to consider 7 neighbor points to this new data point. So if I consider 7 new data points of this neighbor, then most of the neighbors belongs to which class? Most of the neighbors belongs to triangle class. So we can say this new data points is triangle, not the square. So when I'm taking k value 3, we are saying it's a square, and when I'm taking k value is 7, then it's saying it's a triangle. So it's just creating an ambiguity or a wrong prediction of the data. So what should be my k value? How I should identify the k value? That is the biggest task in the case of KNN. Now we'll understand how I can choose the value of k. That question answer we'll try to find out. So to find the value of k, what I'll do, I'll find the square root of n. So what is n? N is nothing but the total number of data points which are available in my data set, and I'll find the square root of n. That will become my k value, and always will consider k value as an odd value. Suppose I got a square root as even value, so I have to convert into a odd value. Suppose I got square root 2. Total I have 4 data points and I got the square root which is 2. So 2 I cannot consider as a k value because always will consider k as a odd value. So I'll at the place of 2 will take here 3. So that in that way we are going to find the value of k. Now we'll understand that how we can do and when to use KNN algorithm. So when we can use KNN algorithm when your data is labeled. In most of the cases, the date when your data is labeled, KNN will work fine. And second thing, when KNN works fine, when your data is noise free, you should not have noise. You can see here in the class label, you have a different type of label data set. This is nothing but noise. Data is not available properly, so KNN will not work in that case. So data should be noise free. And KNN will work with small data set in a better way because we are considering the nearest neighbor in the case of KNN. So whenever you are using KNN and your data set is small, then you can assume that you will get the good accuracy because KNN is a lazy learner. It does not learn from the discriminative features from the training data set. It is taking the decision as per the nearest neighbors. So that's why we are saying KNN is a lazy learner. Understand? So when we can use KNN, when your data set is labeled, when your data set is in small in size, and when you have a noise-free data, in that case, KNN will work fine. Now we'll take example and we'll understand how KNN algorithm works. So you have a data set where we have a height and weight of different people, and according to their height and weight, we are finding the class of that particular person. So as per height and weight, we have classified the people into three classes. One is two classes. One is underweight class, and another one is normal class. So if your height and weight is 51 and 167, we are saying a person is underweight. So in that way, we are classifying the data. Now this is the data which is given to us. And now I got a new data point. I got a new student in my class, and I want to know that what is the label for this particular student whose weight is 57 kg and height is 170 centimeter. And I want to know what is the label of this particular student. It belongs to underweight class or it belongs to normal class. So now how I can do this? So how my KNN algorithm will work? So these are the other data points which I know the value. So these are the data points which I designed or which I plotted in the graph. So these are the data points which I plotted here. And this red dot data point, I don't know it belongs to which class. So I have to identify the class of this new data point. So how I can find the class of this new data point? Okay. To find the class of the new data point, I have to find the Euclidean distance from the neighbor data points. I'll find the Euclidean distance from the neighbor data points and I'll choose the class of new data points. So how to find the Euclidean distance? If you remember, in our childhood, we studied finding if I have a triangle and if I know the value of two edges, I want to find the value of third one. So I have a formula x minus a to the power whole square plus y minus b to the power whole square and root of whole. So in that way, we are finding the distance of third. The same formula we are using here and we have given the name as Euclidean distance. So I know the value of this one and I want to find the distance from this point to this point. So this is nothing but my formula of Euclidean distance. So we'll implement this and we'll find the distance of each data point. So this is my new data point. Now I want to find that how far this data point is from all the data points which is available in my data set. So I'm finding the distance. My distance d1 is nothing but distance from this point to this point. So I know I have a value of this point and I have value of this point. So I kept the value into this x minus a plus y minus b. I got the distance which is 6.7. The same way I'll find the distance from d2. Same way I'll find the distance from d3. In the same way, whatever you are considering the value of k, those many neighbor data points you will find out and you will find the distance from the data points. So for example, we have taken here 3. So we have find out the distance from the 3 data points and my values will be 6.7, 13 and 13.4 and we have taken here k value 3. So when we have taken k value 3 and I found out the distance of each data point using the Euclidean distance formula, you see we got the distance which is 6.7, 13 and so on. Now what should be the distance, what should be the label of this particular class? So you can see here when we'll arrange all these values and we are considering k value as 3 in this case. So I will consider the most nearest data points. So most nearer data points which belongs to the same class. So what are my most nearest values? Which is 1.4, 3 and 2. So if I'm considering k value 3, so I have to consider these 3 value and what is the label of these 3 value? Label of these value is 3, label of these classes is what? Normal. So if it is normal, it means my new data point class will be also normal in that case. I hope you understood what we have done. I'll just give a quick revision of that, what we have done. We considered k value 3 and whatever data points were given to us, we'll take the data set. We have this data set and for every data set we have a class label. Now I have to find the Euclidean distance from the given data point. So I'll find the Euclidean distance from the given data point. I'll get the all values. Now my k value is considered as 3. So I'll consider 3 nearest neighbors which are close to the new data points. So I'll consider those 3 data points. So when I consider those 3 data points, so what was my value? I got these values which is nearest to that. Now, what is the label for these three data points, which is normal? So I'll consider that most of the data points are belongs to normal class. So the new data points also belongs to which class? Normal class. Suppose in this, if two are normal and one is underweight, then I'll consider highest voting. Highest voting is for normal. So I'll consider the new data point as again belong to normal class. So this is the way how k nearest neighbors works. So I hope it is clear that what is the usage of k nearest neighbor. So just a quick recap. First, what we are doing, we are finding a positive integer k is specified along with a new sample. I'll get the k value and I'll find the new sample for whom I want to find the label of the class. We select the key entries in our database which are closest to the new sample, and then we find the most common classification of these entries, and this is the classification we give to new sample data as per the k value. Clear? So this is the way how I am doing the k nearest neighbor classification. Now I'm expecting you people to predict the whether a person will have diagnosed with diabetes or not. We have a one problem statement, and we have a data set available on the Kaggle. In that data set, we have total 768 people entries, and we have mentioned there that person, and there is a label for each entry that person is having diabetes or not. So use this data set and implement KNN so that you'll get better understanding of KNN in that case. Thank you.